Courtoy tablet presses offer improved tablet quality, as well as superior process control, which overcomes compression issues such as capping, low hardness and sticking, thus increasing instantaneous machine output. On top of the tablet press, a rotary dosing valve is installed. This valve eliminates the head pressure and ensures by means of an infrared sensor that the powder level in the in-feed tube remains constant. The double paddle feeder with optimized dimensions has two independent drive motors, one for each paddle. This allows setting separate speeds for the two paddles as well as fine-tuning the process. The heart of the Courtoy compression technology is the Air Compensator, offering a number of advantages. An extended dwell time, up to 300%. Highly sensitive weight measurement, which is especially important for small tablets and low compression forces. Independent weight and hardness control. The safest tooling protection system against overload. The compression cycle of the Courtoy tablet press is quite similar to that of most modern tablet presses on the market. The process of compressing powder into tablets can be divided into 6 stages. At the overfill station, a fixed cam is installed below the first chamber of the double paddle feeder, lowering the bottom punch to a position which allows more than the required material into the die. This ensures that there is enough powder in the die. A wide variety of overfill cams can be used depending on tablet weight. At the dosing cam position, the punch moves up, pushing the excess material out of the die and into the second chamber of the double paddle feeder. The dosing cam is motorized so that the height can be changed. This will be initiated by the tablet press weight controller. The scraper blade installed after the feeder will then remove the excess powder as the die passes by. At the underfill position, the lower punch is pulled down a few millimeters to avoid powder splashing out of the die when the upper punch closes it off, as powder loss would influence tablet weight. The pre-compression has 2 main purposes: removing the air from the powder bed and rearranging the particles, extending the time during which the material is under compression in order to allow plastic materials to flow. At the main compression, the tablet is compressed to its final thickness and hardness. At the ejection stage, the lower punch pushes the tablet out of the die. The tablet is then pushed off the punch tip by the ejection finger. At the very end, the tablet falls down the tablet chute. Formulations are made of different materials with different flow and compressibility characteristics. A tablet press that offers the flexibility to compress those formulations in different ways offers great advantages, not only in terms of tablet quality, but also concerning instantaneous output. The most common method of compressing powder into tablets is with both pre- and main fixed compression rollers. At pre-compression, the powder bed is de-aerated and the particles are rearranged. The dwell time, or the time during which the tablet is under maximum compression force, depends on the linear speed and the flat part of the punch head. The higher the linear speed, the shorter the dwell time becomes. At main compression, the tablet is compressed to an equal thickness. Weight is measured indirectly by gauging a variation of force which has an exponential relationship with tablet weight. At higher forces, this system has good sensitivity, whereas at lower forces it becomes less sensitive. Tablets that do not conform to the force and weight tolerances are rejected and diverted. This method only checks tablet weight, not tablet hardness. Tablet output is largely determined by the fill time and the dwell time. When the rollers are fixed, the only way to increase the dwell time on the overall majority of machines is to decrease the linear speed and thus the output. However, the Courtoy press offers a unique feature, which makes it possible to maintain or even increase the linear speed while increasing the dwell time. The Air Compensator. The pre-compression roller assembly is mounted on an air piston filled with compressed air supplied by the tablet press. The compression force equals the pressure times the surface of the piston. The required force is set on the control system. When the punch makes contact with the roller, it is pushed into the die. The force applied on the tablet increases until the maximum force set in the air compensator is reached. At this point, the roller will move up, which results in each tablet being compressed at an equal force. Compared to a fixed roller setup, the increase in dwell time can go up by 300%. At main compression, tablets are compressed at equal thickness and tablet weight is controlled by measuring a variation of force. Tablet hardness remains uncontrolled. This compression mode offers advantages for large tablets, which require more de-aeration time. The pre-compression station has moving rollers, thanks to the use of the air compensator. The main compression rollers remain fixed. Unlike the two other modes where tablet weight is measured at main compression, here tablet weight is measured at pre-compression. However, not by measuring a variation of force, but by measuring a variation of tablet height. The movement or displacement of the roller is proportional to the material in the die. The displacement is measured by means of an LVDT and transmitted to the weight controller. Unlike the force-controlled weight system, the displacement-based system has the advantage of a strictly linear relationship between tablet height and tablet weight. This makes the setup of the press easier and faster. Moreover, at lower forces or with smaller tablets, this system has a much higher weight sensitivity than the force-controlled tablet presses. The main compression station is used to compress the tablet to its final thickness and to control individual hardness. This is achieved by keeping the average force constant over time. Therefore, both individual tablet weight and tablet hardness are controlled independently and simultaneously. In this mode, both pre and main compression rollers are moving. Therefore, all tablets are made under equal force. At pre-compression, tablet weight is controlled by measuring a variation of tablet height. At main compression, the same force is applied to each and every tablet. This means that regardless of weight variations, each tablet is compressed to the same hardness or porosity. For certain formulations, the extended dwell time at main compression also offers the possibility to achieve higher instantaneous outputs. Compared to the other mode, the machine will keep the dwell time constant regardless of the linear speed. This means that dwell time sensitive formulations, which currently run at low outputs, can now also run at a much higher output. It is clear that Courtoy's innovative compression technology offers incomparable advantages with regard to tablet quality and process control. We offer all our customers the opportunity to test their formulations in our centers of excellence in Europe, North America, and Asia. Courtoy, the true innovator in tablet compression technology.